Hello everybody and welcome to another Viz Network how-to video. I'm your host Tom Crawford and today we're taking up the fourth topic in our series on well-formed data for charts and graphs. And today's topic is missing data. So rarely do we get good, clean, complete data. Often what we get is incomplete, it's not formatted properly, it's not at the right level of detail, pieces are missing, and that makes it really hard, if not impossible, to actually make a good chart or a graph. So before we get there, we actually have to figure out how to deal with that missing data. And there are really two types of missing data. Data that's actually missing or can't be figured out, and then data that's implied. There's some other data in the table, in the information, that actually can help you extract additional information that may be missing. So first, let's take a look at the data that's actually missing and how to deal with it. You may think, well, there's nothing you can do. It's missing, so you just move on. Well, unfortunately, it's not quite that simple. So let's take a look at this example. In the customer field we've been working with over the 4 videos, there's some missing data. Sometimes it's indicated by something that's partial. So in this case, only the extension. The reality is, you could never call this person anyway. So that is pretty much missing data. Now maybe if you knew the company name, you might be able to extract from there, and maybe that comes under the other category, but we don't have company information here, so the extension is pretty much useless. Then there's other fields that are blank or seemingly blank, and we'll talk about that in just a second. Or often people will put in a placeholder of some sort, not applicable or none or refused, or some other word that happens to be in this phone number field. So why is this a problem in the first place? Well, if you try to chart this information or graph it or even use it in some automated way, the text fields, the blank fields, the incomplete fields will all cause problems in that process. So to clean up this data, my recommendation is that you actually add in a whole new column. You could certainly modify the existing data. However, if you ever want to go back to it, need the source, or need to know what was originally there in case something happens, having the original data there is very valuable. So, create the new column, copy the data over, and simply delete the bad data. That's one way to handle this. Now, when you get to numeric fields, it's not quite so easy. So let's go back to the data and see why this is important. First, not everything that you think is blank is actually blank. I know, confusing, right? Excel has a function called isBlank. What that does is check to see if there's any data at all in the field. So let's take a look and see what that really means. So okay, in H2 there is actually a value there, so it is not blank. So let's copy that down and see what it says for the rest. Interestingly, only one of our fields is blank. So let's try to see with a different function what's really going on here. And we'll use the length function, a very handy function that we used in an earlier video. So we're going to do length of H2 again. And it's 12, a very standard phone number length, so that's good. Let's copy this down. So look at that. There's actually a space in H9. So let's see what the impact of that really is. Let's say we're going to take all of our phone numbers and divide them up among our employees to call our customers with a new product we're going to offer them. So to know how to divide them up, we've got to find out how many phone numbers we have to call. So one way we can do that is simply count them. Well, Excel has a nice little function called count A. Count A really may be counterintuitive in some ways because it counts anything that's text. That's the A part of the count A. And you might say, well, phone numbers are numbers. Well, because our phone numbers include dashes in this case, or yours might include parentheses or something else, you have to count it as text. And in this case, it comes up with 10. Well, we have 11 customers in our database here. It sees only one of those as blanks. But really, we only have 6 phone numbers, so we divide up the phone numbers to call completely wrong. So on the other side of it, Excel also has a function called count blank. Count blank is used to find out the opposite information. How many of our rows are actually blank? Well, in this case, it says only one is blank. We know that there are at least 2 that are visibly blank, and probably 3 others that should be blank as well. So a different approach might be to actually use the length. So we're going to put in a special field here. We're going to call it length phone, and we'll use the length function. Copy that down. And now we can say count if the value of that field is 12, and it turns out we have 6. So there you go. We know we need to call 6 phone numbers. We can also then filter on this and say show me the only ones that are 12, and then we'll be good to go for our phone list. My recommendation for text fields is if the data is incomplete, whether you put in none or NA or a space or a partial piece of information, is to actually leave it completely blank in the fields you're going to use, much as we showed on the previous page. However, for numbers, it's a little bit different. So let's take a look at how this is different for numbers. We have 3 columns with the exact same data in it except for our missing data. The first column is all numbers and the missing data is represented as a 0. In the second column, it's represented as a space, and in the third column, it's represented as a blank. While this would be true for any math function, let's take a look at one of the most common, which is average. We're going to average all the numbers, and as expected, the average comes out to 5 in the first column. However, if we take that and copy it to the second column and the third column, our average is 5.5. That's because in Excel, it doesn't count the space or the blank as part of the average. You have to be very careful in different programs, in different languages, and different computer systems because they all deal with spaces, blanks, and nulls very differently. So when you're doing it, you need to make sure that you understand what it is. Now, should you put a 0 in if it's actually a space or a blank or the data is missing? Well, that depends. Do you know it's a 0? If you know it's a 0, then maybe you should put it in. If you don't know it's a 0, there may be other ways to deal with that. So now let's take a look at implied missing. Take, for example, the postal code in our spreadsheet here. Postal codes imply cities and states. So you can actually infer that from here, that postal code 48105 is actually Ann Arbor, Michigan. And filling in that data is appropriate. Now sometimes, however, some postal codes do have multiple cities or may represent different areas. So it's not a perfect match, but in a lot of cases, you can make that assumption. In fact, implied data is all over the place. From a GPS location, you can get everything, address, street, postal code, all the way up to continent. However, if you only have region or state, you can't actually assume the address or the street or the postal code because the information is too high. You can always go to higher levels, but you can never go to lower levels. So when dealing with implied data, I always recommend that you store the lowest level of data possible. So if you have the address, store the address, because if you want to roll that up into state or region or country at some point, you can always roll it up, but you can never back it back out. So always store the lowest level of data. In fact, implied data is all over the place. Another common example is in date and time. If you store date and time down to the second, you can always go to the higher level of century if you ever want to. But if you're storing down to the second and for some reason you want to do time trials, that information is already there. So you have everything you could possibly need for any kind of roll-up. So the rule with implied data is always store the lowest level. If you have the lowest level and need something higher, you can always use any number of Excel formulas or arithmetic equations or any number of ways to extract the data that you need for your particular calculation. So there you go. You now know the major components to create well-formed data for your charts and graphs. Thanks everybody, and I'm looking forward to seeing you on the next Viz Network how-to video.